backdrop there, leading us to be fairly depressed. A quick bit of audience participation. Who thinks that we should try to do something about these problems? This is actually just one of those tricks to wake up the audience. And who thinks that that's going to be really easy? Yeah. Okay, Ove's going to present the rest of the talk. So, as I've said, I'm Laurence McCook. My participation in the work of the Centre is supported not only by GRBMPA, the Great Barrier Reef Marine Park Authority, but also by a Pew Fellowship in Marine Conservation. Am I talking loud enough at the back if I miss the microphone? Okay. But I also want to acknowledge some co-authors. The Climate Change Group are major contributors to the stuff about climate change, and indeed the entire Marine Park Agency, Marine Park Authority are co-authors when I'm talking about resilience. So I'm going to change the context here. We've had a series of very impressive scientific talks. I'm going to change it to a context which starts not with the science, but with the reef itself. The Great Barrier Reef is a place of extraordinary environmental and ecological value. We've heard about that. It's a place of extraordinary social and economic value, an estimated $6.1 billion a year to the Australian economy. With those values come some real responsibilities in terms of protection. And unfortunately, those values, as we've heard, are under threat. So we've seen a series of sequences of pictures of reefs degrading and being bleached and so on. I'm using as my example the 2006 bleaching in the Keppel Islands, where there was fabulous coral cover in many areas in the Keppels, severe bleaching in the summer of 2006, leading to some recovery, but also to fairly extensive algal overgrowth of the bleached corals. Now, I'm happy to say that there was actually quite impressive recovery in many of those areas that were overgrown. But my point with this sequence here is to say that from a management point of view, we have three challenges, if you like. We want to reduce the likelihood of that happening. When it does, and Ove and all the rest of you have convinced us that it is going to, and it's going to happen more frequently and more intensely, when it does, we want to increase the chances of that happening, of corals recovering, individual corals recovering, decrease the chances of this happening. And then finally, when this does happen, and again, we're now convinced that it is going to happen and happen a lot more in the future, we want to increase the chances of this happening. So how do we go about that? Just a quick outline for the talk. I've kind of identified the challenge for you, if you like. I'll talk a bit about how we go about responding to climate change and, in particular, the Great Barrier Reef Marine Park Authority's climate change program, and two key elements of that program: the vulnerability assessment for the Great Barrier Reef and the impacts of climate change, and the climate change action plan. Then what I want to do is move on to look at resilience. I'm going to focus on ecological resilience and just do a quick review of what we know about the factors that contribute to ecological resilience on coral reefs and marine systems, and how we're going on the Great Barrier Reef at addressing those things. But I'll end up with a quick emphasis that these things need to be linked to social and community participation and social resilience. So, sorry, it's a bit of a struggle here. Essentially, there are two things that we can do about addressing climate change, and in fact, the stresses on reefs generally. This shows you a time sequence. This diagram shows you a time sequence in which we're now fairly clear that the stresses acting on reefs are increasing dramatically and are going to continue to increase dramatically for some time. The presumed consequence is that we're seeing significant degradation and decline in the condition of reefs, and the real concern is that that degradation may take us past some threshold beyond which reefs or ecosystems don't have the resilience to recover and regenerate themselves. Now, there are obviously two things that we can do about that. First and foremost, and as we've heard a number of times, critically important, we can aim to reduce the stresses, reduce the extent and the rate of the stresses affecting the coral reefs. And that's most critical with climate change. And it's worth emphasising that that is going to be the strategy which is most effective in the long term and is also most cost effective, because everything we do to reduce climate change is not only going to be of benefit to the Great Barrier Reef, but it's going to be of benefit to an enormous range of other ecosystems and social and economic systems as well. So it really is critically important. However, it is also true that even as Ove and Malcolm and so on have told us, that even in the most optimistic scenarios, we are now going to see inevitable ongoing stresses to reefs, in particular through climate change. So the other thing that we must do is work very hard to ensure that the extent to which reefs degrade does not go past this kind of threshold beyond which recovery is much more difficult, so that we can, in the long term, see recovery and minimise the extent of damage to reefs. And that's basically involves trying to maintain the resilience of the system at the best available levels. So to go through that again, in text form this time, we need to reduce the extent of the problem, greenhouse gas abatement. That at the national and international level is the most critical level. That's obviously not the mandate of an organisation like the Marine Park Authority. It is the job of the Greenhouse Office. But we all have a responsibility at local, regional and personal levels to reduce our own footprints. We mentioned minimising the impacts, maximising the resilience. That's what the climate people call adaptation, loosely speaking. Significant change is inevitable, and we need to be thinking not only about the ecosystems, but the social and economic systems as well. Now, a key... So these are the two primary initiatives, if you like, but there's a really important derived initiative or secondary initiative, and that is about using the science that we're hearing about and the monitoring and so on to document the extent of impacts, the extent of damage, and use that in turn for awareness raising through communication with policymakers, governments and politics, and the public. That was a Freudian slip, wasn't it? There is a real potential through these mechanisms to significantly enhance the effectiveness and the commitment to the other two primary initiatives. So that's really worth emphasising. Okay, what I want to do now is talk for a little bit about what's going on at the Marine Park Authority, and in particular I should acknowledge the strong support provided by the Australian Greenhouse Office for a number of years in supporting our climate change program. So the Marine Park Authority for a number of years has had a climate change response program that started out as an offshoot of the research and monitoring section and is now a fully fledged program, a critical issue group in its own right within the Marine Park Authority. It has four main focuses, if you like: assessing the vulnerability. I'll talk about that in a little more detail in a moment. It has monitoring the impacts, so this is that contributing to the raising of awareness. And I wanted to particularly highlight in this coral bleaching response plan one particular element, the Bleach Watch program. This is a community-based monitoring program which draws on members of the public at large, scientists, and in particular the tourism industry to dramatically increase our first awareness, if you like, our early warning system of the occurrence of bleaching on the reef every summer. And then finally, managing for resilience. So I'm going to talk now for a moment about the vulnerability assessment. This is this volume here, which is highlighted there. This is a massive amount of work by a very large number of scientists. Many of you here in the room contributed to that. And I'll just summarise that very briefly. Basically, what that assessment did was it looked at a range of taxa, so things like corals, fishes, algae, seagrasses, microbes, trying to be as comprehensive as possible, but also a range of habitats, reefs, pelagic systems, seagrass beds, mangrove systems, and so on, considering in particular processes and also considering the human elements of the combined social and human system, the social and ecological system. And for each of those different groups, the approach that the assessment takes is an accepted approach in vulnerability assessments, especially in climate change. It considers the exposure to each of the different climate change stresses, the sensitivity of different groups. Corals are obviously different to fishes and to seaweeds and so on, and combines those to derive a potential impact. That impact is then moderated by the perceived adaptive capacity of each group or habitat to derive an overall vulnerability. Now, it's pretty hard to, and for each of the groups, we tried to do that for a comprehensive range of climate effects, from sea temperatures through to acidification, storms, etc. Now, it's very hard in the time available to summarise 5 kilos of work, but so I'll just highlight a couple of points. There were some areas that were no surprise. The vulnerability of corals and hence of reef ecosystems generally was particularly emphasised, but there's a few that you may not be as aware of. So, for example, the microbes and the pelagic systems, the phytoplankton and so on, turn out that there is a lot of potential vulnerability there, and that's potentially really important because we're essentially talking about the atmosphere, if you like, the environment at large of the marine ecosystem. So major changes there can have major changes for the entire system. Also things like changes in ocean circulation and temperature can have major effects on bait fish distributions, and that in turn can have major effects on the feeding and breeding success of seabirds. In turn, in some cases, we've seen major declines in the breeding success of entire seabird rookery populations. Okay, the other major aspect of the climate change program I wanted to talk about is the Climate Change Action Plan, which is a forward-looking document. It has the overall goal of increasing the chances of the Great Barrier Reef coping with climate change, or increasing the extent to which it does, and it has 4 major elements, as you see here. Targeted science, so addressing some of the knowledge gaps that we're seeing appear this morning and today. Managing to enhance the resilience of the GBR ecosystem. We'll go on to that in a moment. Considering the resilience of the human dimension, the people and the communities and the industries, and then focusing on reducing climate footprints. So that's a very quick summary of that document, and I have a copy here that people can have a look at if they'd like to. Okay, so as I said, a major element of that is focusing on resilience, and in particular the ecological resilience of the reef or the marine park to cope with climate change, and indeed to cope with the entire suite of stresses that are impending on the ecosystem. And this is really the job of the entire Marine Park Authority. Terry's going to talk more this afternoon about what resilience is and how we go about and what we can do about it. But just very briefly, for those of you who aren't familiar with the concept, it's about the ability of a system to absorb disturbances and resist major changes in the state or the nature of the system. In particular, its capacity to regenerate, reorganise and maintain key functions and processes. So the easy analogy is in terms of human health. Healthy people tend to be better able to resist diseases and to recover better from diseases when they do get them. To apply that illustration to reefs, coral reefs are naturally subject to significant amounts of disturbance. The critical point in terms of resilience is whether they can recover from those disturbances and keep on recovering from repeated disturbances in a wide variety of different forms. So, there's been a great deal of science applied to this question over a number of years, and a number of principles or strategies have been identified that can enhance the resilience of tropical systems, in particular coral reefs. So what I want to do now is to actually do a quick review of those different strategies on the left-hand side in each case, and just have a quick look at what is being done on the Great Barrier Reef, not just by Grabumpa, but by other agencies and natural resource management people to address those issues. So science has identified the need to reduce chronic stress. the environmental quality of the system, in particular water quality, and many people have referred to the Water Quality Protection Plan, but also the emerging stresses of climate, and we've talked about the climate change programs that are going on. Secondly, the science tells us we need, as far as possible, to reduce the frequency of disturbances to the extent that they are human-derived. So things like coral bleaching and cyclones may be, they are increasing as a result of climate change, and we've talked about climate change already. Crown of thorns, a major disturbance on the Great Barrier Reef. To the extent that it's a human impact, it may be contributed to by water quality and or by overfishing of the predators on the larval and juvenile stages. The zoning, the Water Quality Protection Plan and the Fisheries Management Plans, which are Queensland state government initiatives, are relevant in that context. And then finally, one of the major disturbances to non-reef habitats is trawling, and there have been major changes to the trawling industry and the management of trawling in the last decade or so. Okay, what else does the science tell us? It tells us that we need to protect biodiversity at a range of levels, species, habitats, and functions and processes. And related to that, in particular, is protecting refugia, that is, areas that are likely to serve as sources of propagules of corals or fish or other groups, and the connectivity that allows those source reefs or source habitats to provide the capacity to recover to areas downstream. One of the major initiatives and is in addressing this is the rezoning of the marine park in 2003-04, and in particular the fact that that zoning depended on a comprehensive representative areas program which worked very hard to ensure that the different types of habitat and species were all represented comprehensively, representatively, in replicated fashion, and perhaps most critically of all, adequately. These, but the REP Areas program doesn't stand alone in the rezoning. It also integrates with fisheries management plans, with plans of management, impact assessments, and at the level of individual species such as dugong, we have specific plans, the dugong protection areas and so on. This is also, all of these things are very relevant to protecting refugia, potential sources of recolonisation capacity, if you like, and connectivity. And I've just come from a workshop run by the Centre of Excellence looking at updating what we know about connectivity, and we worked very hard in that workshop to try to think about how we can apply that improving knowledge to developing new management strategies. And what emerged is very clearly that based on what we currently know, the kinds of strategies we've been taking are really important. Okay, the science tells us that we need to be considering key functional groups and processes in the ecosystem, and in particular looking after the trophic structure, that is the food webs. And on coral reefs in particular, there's a couple of groups that are of critical importance, especially the herbivores. Now, on the Great Barrier Reef, as in many places in the world, we've now lost a large proportion of the large herbivores, things like dugongs and some of the herbivorous sea turtles. That means that the roles of other herbivores, in particular herbivorous fish, is all the more critical and important. We're fortunate on the Great Barrier Reef that there are a number of mechanisms that provide protection, perhaps incidental protection in many cases, but there is a fairly robust situation there. We are considering trying to tighten up that protection. But also really important are the higher level predators, things like sharks and so on. Howard Choate will talk about more about this tomorrow, but there is a lot of effort going into increasing the protection of sharks as we speak, in particular through the fisheries management plans and a number of other processes. Okay, the science tells us that we need to consider some other key functional groups, and in particular processes which might serve as bottlenecks for the recovery of the system after disturbances. And one of the key aspects there, given that corals are the builders of reefs, is the blocking of coral recruitment after disturbances by the kind of scene I showed you before, when algae overgrow the reef. Now, that's fairly challenging to manage directly, perhaps the best way is to manage to ensure that we have herbivory, because the herbivores will deal with the problem for us. But it is an area where we need more research. Okay, that's the main ecological points. It's worth pointing out that none of this stuff stands alone, that we need to be thinking about aspects such as management styles, governance, and the importance of managing for uncertainty and having margins of error, because many of the threats that we're going to deal with are to some extent unpredictable. John Tanzer is going to talk about adaptive management on the Great Barrier Reef more tomorrow, so I'll leave that for now. What I do want to do, though, is remind you that a very large proportion, 95% of the area of the Great Barrier Reef Marine Park is not, in fact, coral reef. It is interreefal seabeds, seagrass habitats, sponge gardens, and so on. Now, in terms of the resilience of those systems, we have a much greater challenge. We know far less about those ecosystems than we do about coral reefs. That means that understanding the threats, the pressures, the interactions, and so on is much more challenging. Does that mean we don't? So we do need more research in those interreefal areas, and Ian referred to some of that this morning. But that doesn't mean we don't do anything until we've done all that research. What we can do in the meantime is manage the known pressures, in particular aiming to maintain the physical, the ecological and the chemical processes as intact as we can. And the pressures that we're trying to address there are trawling, line fishing and runoff. But also ensuring that through the Representative Areas program, major proportions of habitats are protected from known and likely pressures. Okay, the other aspect that's particularly important from a management point of view is so-called species of conservation concern. The things like dugongs, cetaceans, turtles, sharks, and so on. Now, these are a real challenge in terms of resilience, because many of them have low reproductive rates, but many of them have real bottlenecks somewhere in their ecology. So turtle nesting sites are a particular vulnerability, especially with impending sea level change. Seabird nesting I mentioned previously, the migration routes, and many of them in fact have habitats which are international in scope, making their management very challenging. All of this often means that the populations, even under the best possible circumstance, when you remove all the current pressures, recovery times may be very, very slow compared to things like reefs. Okay, so just to finish up, I want to just have a think about what resilience brings to management, given that many of the initiatives I've talked about were things that we were already going to do, or any responsible management agency would already be doing. And I think there are essentially 4 or 5 things that the resilience approach really contributes, which are really important. Firstly, it explains the need to the broader public, and in that I include people like politicians and policymakers and so on, the need for integrated management. That is the awareness. So when I was talking about water quality in the Great Barrier Reef catchment in 2002, many people would say to me, just as climate change was becoming realised as a threat, people would say, well, why are you bothering with water quality when you're now telling us that climate change will kill the reef anyway? And what we're able to do through the resilience concept is illustrate to them that climate change means all the more why we need to address water quality rather than needing less to address water quality. Resilience also serves as insurance against unforeseen future threats, and the emergence of climate change, which we'd hardly thought of 10 years ago, some of the more far-sighted people might have, is a real illustration of how we need to be protecting against those kinds of unforeseen and unknowns, the unknowables that were referred to this morning. Resilience provides a clear framework for integrating our attempts to manage ecologically with the importance of an awareness of social and economic aspects. I'll talk about those very briefly in a second, and Terry will talk about them more later on, I'm sure. And finally, and perhaps most important, the resilience framework places a great emphasis on the need for proactive management initiatives. So we need to protect the resilience of the Great Barrier Reef while we have it, not wait until we've lost it. So just to finish up with emphasising the importance of community engagement, community participation, and the importance of social resilience going hand in hand with ecological resilience. So for example, this is a couple of banana growers who are working very hard to reduce the runoff from their industry, from their farming practices to the water of the Great Barrier Reef, but in doing so, looking for win-wins so that they can increase their economic resilience. This is a couple of people from the tourism industry who are helping us with our water quality monitoring program to assess the effectiveness of the reef water quality protection plan. There's very strong buy-in from the tourism industry to that plan. However, it's worth noting that in many areas of the world, and Gary will talk about this this afternoon or tomorrow, Gary Russ, there has been much greater uptake of the importance of some of the things I've been telling you about. Sadly, because these people have seen firsthand the consequences of not addressing the issues that we've been talking about. And I'm really hoping that we don't need to go that way, that we can actually maintain the resilience of the Great Barrier Reef, that we can keep it great. Thank you.
Questions for Laurence?